Hi friends, if you remember yesterday we started learning about exponential functions. Today we're going to be doing a little bit more work with exponential functions, but just to remind you of what exponential functions are, there's something that grows by equal factors over equal intervals. So remember we were talking about linear functions, they grow by equal differences. An example of a linear function was if we were going to open 20 new stores each year, so every year we're increasing by 20. An exponential function, one example we saw yesterday was that we were doubling the number of stores. So our difference doesn't stay the same with an exponential function. However, we see that our factor stays the same. Whatever we're multiplying or dividing by stays the same. So if we're doubling the number of stores, we're always going to be multiplying by 2. Remember yesterday, we also talked about the form that our exponential function equations take, and that was y equals a times b raised to the x power. Remember, we knew that y was our output, x was our input, b was our growth factor, and a was our starting amount. Or value. So let's look at what I had you do for homework, just so we're all on the same page. Right here, activity 3.3, multiplying microbes. It says, for number 1, in a biology lab, 500 bacteria reproduce by splitting. Each hour, on the hour, each bacterium splits into 2 bacteria. So if we think about that, if one bacteria splits into 2, is our bacteria going to be increasing or will it be decreasing? Take 30 seconds to think about that. If one bacteria splits into 2, is it going to be increasing or decreasing? Awesome, I agree. I think it would be increasing. So at 0 hours, we're starting off with 500 bacteria. We know that just by reading our example. Then we know that each bacteria splits into 2 bacteria. So for every 1 bacteria, you're going to get 2. If we had 2 bacteria, we're going to get 4 bacteria. If we had 3, we're going to get 6. If we had 5, we're going to get 10. So what operation is happening? What operation is happening? Take a minute to think. What do you think? Awesome. I agree. 1,000 because we're multiplying by 2. And let's see, our 2, we're going to multiply. And we're going to get 2,000, then 4,000, then 8,000, and then now we have t hours. We need to think about what's happening. How do we figure that out? That is when our exponential function notation comes in. So we know that I have y equals a times b to the x power. That's our input. So what we're going to do, can you tell me what your growth factor is? Awesome. I agree. We have y equals, we know that our growth factor is 2 because that's what we're multiplying by each time. We leave the x there. Now remember, our starting value is always going to be in the form 0, a. And we can see right here, we have 0, 500. So we look at our table, which gives us some information to help us solve that. So we would have 500 times 2 to the x power. Luckily for us, right now, if we want the hour t, our input is going to be t, not x. So we just have to change that. Next, it says for us to write an equation relating n, the number of bacteria, to t, the number of hours. The one thing we need to change is just the variable y. Our input is now going to be n for the number of bacteria equals 500. our starting value times 2 raised to the t power. We can check to make sure that we are solving this correctly by plugging in one of our values. If we were to have t comma n, we could look at that we have 1 comma 1,000. So I'm going to plug this into this equation just to make sure. I'm going to see, does 1,000 equal 500 times 2 to the power of 1? 500 times 2, which equals 1,000. So 1,000 equals 1,000. Check. I know my equation is correct. Use your equation to find n when t is 0. What does this value of n mean in this situation? So in this case, we were able to look at our data and solve. However, sometimes there might be some cases where you can't look at what you have to figure out the starting value, and you're going to have to plug in what you know, similar to what we did over here. You might have to plug in what you know and solve for that a value. Let's just double check, though, to make sure our starting value is 500. So let's see. We would have n equals 500 times 2 raised to the 0 power. N equals 500. Remember, anything raised to the 0 power is 1. So n equals 500. We can say in this situation that at 0 hours, there are 500 bacteria. So we start off with 500 bacteria. Please ask me a question if you have one. All right. Now let's look at number 2 from the homework. It says, in a different biology lab, a population of single-cell parasites also reproduces hourly. An equation which gives the number of parasites p after t hours is p equals 100 times 3t. Explain what the numbers 100 and 3 mean in this situation. And right here, I think there was a mistake. This should be 3 raised to the t power. So right here, we have, remember, y equals a times b to the x power. We might just change around our variables, but let's see. 100 corresponds to what variable in this upper equation right here? Awesome, I agree. It corresponds to a. How about 3? What variable does 3 correspond to? Y? No. X? Definitely not. B? You got it. So explain what the numbers 100 and 3 mean in this situation. So if we think about what we talked about, do you remember what does the variable a represent? Awesome. A was our starting value. So that would be the starting amount of parasites at 0 hours. Now let's look, what does 3 mean? Awesome. 3 is our growth factor. Take a minute to look at your work and just double check that you are also correct. Remember, this was the problem that you had to do yesterday for homework. I think it would be really good if you take a look at what you had to do for homework, take a look at what I have for my answers, just so you are on the same page as me, and let me know if you have any questions. All right, I'm just seeing right here. And just, growth factor. Another way we can think about our growth factor is that just like when we had a growth factor of 2, we were doubling. So a growth factor of 3 means that the amount is tripling each hour. Please let me know if you have any questions. Otherwise, have a great day.